We can use limits to deal with things that we've already dealt with before, but now we're just going to formalize them using limits. So horizontal asymptotes are something that we've done before. And what we're looking at is a rational function, whereas we let x go to 0, x go to infinity, we're going to end up with a y value going to positive 2. So the way we did it before was we usually looked at the two highest powers and took the ratio of those two highest powers and said that, well, if x is infinite, then really we're just comparing the highest powers. So you get a y value of 2. So we end up happening is we get a horizontal asymptote at y equals 2. And we can do the same thing for negative infinity, because this one here has a horizontal asymptote going to the negative. So the limit as x approaches negative infinity of f of x, we know that it's going to have the same ratio, so we're going to have it equaling 2 from the left hand, going to the left as well. So this is how we dealt. We're going to now use a formal notation to indicate these horizontal asymptotes. Okay, so and that's what we have here. That's what I've drawn down here. As x goes to positive infinity, we know that the y value tends towards 2. And at negative infinity, we get the same thing. With vertical asymptotes, again, we're going to formalize this because we know that we can write a limit that helps us get the asymptote. So although we know that the asymptote is going to be the term that doesn't cancel, so we have these terms canceling, and we know that the vertical asymptote is going to come from that x minus 1, so we can see the vertical asymptote happening at x equals positive 1 here. We can do this more formally with a limit now. So the limit as x approaches 1, now it's going to be different from the left side than the right side, because we can see it's going up here on this side and it's going down on this side. So we're going to have to do one-sided limits. So 1 from the positive side of f of x, and we can see that's going up to positive infinity. And then we can do x as we approach 1 from the negative side of f of x. That's going to get us to negative infinity. And this is how we now formally show our vertical asymptote. Okay, we can show it as two one-sided limit, one going to infinity and the other one going to negative infinity. And just to note that because the two sides are different, although we have the limit as x goes to 1 of f of x, we have to say that this does not exist. Okay, so as a two-sided limit, it does not exist. So we have to split it up into its one-sided limits. Now lastly, it's the whole. Now again, before we've dealt with these wholes before. So we know we have a whole at x equals negative 1. And if I were to plug, the way we dealt with it before was we just plugged in the whole value, the y value, into that. So at x equals negative 1, we just plug in negative 1 into the equation. So we end up with negative 1 plus 1 is 0. And we end up with negative 1 minus 1 in the denominator. And so the whole value is going to be the y value. So we say that y equals, let me just clean this up a little bit. At x equals 1, we say that y is equal to 0. Okay? Now we're just going to do the same thing, but now we're going to formalize it using a limit. Because a whole doesn't actually exist, we just now should say, as x approaches 1, negative 1, of f of x, that's going to approach a y value of 0. So then we have, this formally establishes there's a whole at negative 1 and 0. Now we've done this before, okay, at negative 1 and 0 there is a whole, but now we're introducing this limit notation to do it more formally. So this is just a new layer on something we've already done. We're just now using formal notation to deal with vertical asymptotes, horizontal asymptotes, and wholes.